first problem. Alrighty, so I'm going to read it first. A metal block, right, has a mass of 325 grams. Now I tell all my students, right, all the time, don't read this problem quickly in a rush and then go, oh my goodness, I can't do it. There's so much information, I'm confused. Read it slowly. A metal block has a mass of 325 grams. You stop there and you ask yourself, okay, what variable is that guy in 325 grams? And we know from experience, right, that's mass. And when you're doing a test or a quiz, maybe you could write a little M above it, okay, to ensure that, okay, I know that's mass. Okay, you move on. If it takes 9,500 J, which is joules, right? You stop right there, okay? 9,500 J, joules. That refers to heat energy, right? So now we know our mass, we know how much heat energy it took. So we know two of the variables in our triangle, okay, our magic triangle. So we move on. To raise the temperature from 35 to 55 degrees C, you stop again. The temperature changes, right, from 35 to 55. Okay, we know from experience, right, our delta T means temperature change, right? So in our minds, we know that the 35 to 55, we do simple subtraction, you're gonna get 20 degrees C is gonna be our temperature change. You make a note somewhere on the side. Okay, so I know my mass, I know my joules, my heat energy, I know my temperature change. Okay, you continue reading. What is the specific heat of the block? Okay, so what we're gonna do, we're gonna solve for specific heat. Now, once again, folks, you gotta know the letters, right, and what they mean. Okay, so let's draw a triangle again. So here we have, okay, you have Q is equal to MC delta T, right? Okay, now, we looked at this problem. We know this is our mass, 325, right? So we know what the mass is, okay? 9,500 J, we know that's our joules, right? So we know what Q is, that's our heat energy, right? Okay, we established that this from 35 to 55, that's gonna be our delta T, yes? Okay, and that will be equal, the difference will be equal to 20 degrees C, okay? So we know what? Our Q, heat energy, our mass, and our temperature change. And specific heat, guys, the letter in the triangle is C, right? Capital C right there. Okay, so that's what we're looking for. Now we have the triangle here. Now what you can do, if you have issues with algebra, no problem, you can put your fingers over the C, right? And what are you left with? You're left with Q over M times delta T. So you write it out someplace. Q is equal to, oh goodness, C, all right, is equal to Q over M times delta T, okay? No problem. And you plug your numbers in. Now guys, don't plug the numbers in without the units. If the units don't cancel properly, it's an indication you probably made a mistake, you can fix it. But if you just put magical numbers in there without any units, problematic, you make a mistake you don't know, okay? So our joules, our Q is 9,500, all right? Joules, J, okay? M is our mass, this is 325 grams, okay? We're not guessing where the information goes, we know where each item goes, okay? And our change in temperature is gonna be 20 degrees C. Now look carefully, folks. We got joules on the top, yes? We got grams on the bottom, we got degrees C on the bottom. None of those units cancel, and that's good, because it just so happens for a specific heat, right? It has all of the units in it, okay? It has joules over grams degrees C, or sometimes it has Kelvin, right? But we know that the degree C difference and the Kelvin differences are the same, so they're interchangeable. All right, so we're happy. So you do your calculation from there. Okay, you could simply do 9,500 divided by 325, and then divide it again by 20, right? And you should get something around 1.46 joules gram degree C by my estimation, or my calculation. Alrighty, and you're done. Bam, that's your answer. Okay, remember, you included your units, you're good to go. All right, we'll do some more in a second.